All right. So this week we're gonna have a brand new exciting change to what we've been doing. I'm very excited for show and tell, which will happen very soon. It comes up fast. But I'm really excited to see what happened for the show and tell, but then also for us to get started in a whole new section of Make Haven. So we've been working excitedly in the wood shop. There's been lots of cool stuff that got made over the past week or so. People really brought together some projects or are excited to be doing that. And now we're going to switch gears to another one of the major, I would say, thirds of Make Haven, which is the metal shop right through that fire exit door behind us. And so we're going to be excitedly headed in this direction. And you're going to see that there's lots of things that are really analogous in the metal shop. And you're going to see that there's also lots of things that are fairly different. And so it's exciting to get going. An overview of what we're going to talk about today is we're going to take a look at identifying metals in general, which sounds kind of silly, but it's worth looking at for just a second. We'll talk about metal tools, sort of hobbyist level, machinist level tools, and make a distinction between those two levels of engagement. We'll talk about working with metal in general, precision measurement, which is something that many of you already seem like you have a good knowledge of. But we're going to go over the sort of the basics of how you would do that and how you do it well. And then we'll identify some starter metal projects. Not that it'll be a lot like how we did the 2 weeks of wood shop, the 2 weeks of metal shop. This week's going to be mostly for badging, but sometimes, especially in the metal shop, it can be helpful to think about how you get your badges based on the project that you kind of have loosely in mind, and which is likely what you just learned over the past 2 weeks. And so we'll be taking a look at how those pieces fit together, and hopefully you'll have some fun. Let's see. So with that, we're first going to talk about identifying metals, which is fascinating. I'm a high school chemistry teacher. There's even a chemist among us. And so most of the periodic table is metals. Most of the atoms, there's 118 elements. We do have those last ones in the bottom figured out, but almost all of the elements are metals. And so, which is fascinating. Most of our planet by mass is metal. There's tons of metal all over the place, and it gets used for all sorts of things. Iron is definitely going to be the biggest player in that game, but there's lots of other really fun metals to play around with. But just in general, if you're trying to understand metals, the huge category for what's going on there, I want to also say that it is a deep, deep well that you can get a degree in metallurgy, right? You can absolutely go very deep in just this stuff. This is just the blend of sort of like carbon to iron and its temperatures and different things that happen so that you can get different versions of steel. And please don't try to understand that right now. If you already do, awesome. But what is really neat is that metals, like water and ice, will melt at a certain temperature. And so you can get molten metal. You'll get this glowing effect down here. This is an effect called black body radiation, where things that get hot enough, they start to emit light just based on their heat. And so that's a really interesting effect that we'll look at and sort of think about as we're working with metals over the next couple of weeks. And then another thing to think about with metals is that they have this sort of almost crystalline structure. And this image here on the right is really a neat way to sort of look at boundaries inside of a metal. It's different than wood. Wood had those fibers. We talked a lot about grain over the past 2 weeks. And in metals, it's different. It's sort of one solid mass without any fibers. There are grains, but really it's sort of a solid thing without any pieces or internal structure very much. That's easy for us to get a hold of. One of the things that's really worth thinking about with metals is that they are very hard. And maybe that sounds obvious, but toughness, and some of those properties can really be quantified with things like metals. And so when you're talking to the metal facilitators, they'll probably reference things like a hardened steel versus a cold rolled steel. And those different metals have very different workabilities. And then you've got something like aluminum, which is a much softer metal. And so there's all sorts of range that goes along with that. If you want to actually gauge hardness, there's multiple different scales for measuring it. And it's essentially how well something can scratch something else. And so not all metals, not all materials are the same hardness. And in the wood shop, that doesn't usually come too much into view. Like we think about softwoods and hardwoods. But in the metal world, it often is something that can be a little bit more easily quantified. The metals are usually more uniform, and it can be more important. If you're trying to make a tool versus if you're trying to make a table leg or a support, you might have different hardness needs. And that, which really, like, instead of trying to get too granular with hardness scales, what's really interesting as a dynamic, I think, is to think about materials this way. Is sort of this spectrum that's here. And I love that tempering color piece. It gives you a sense of sort of, there's a lot to unpack there. But you can either have materials that are sort of soft and pliable. Think like the extreme example is silly putty, right? It's soft, pliable, it'll squish, it'll move. It can be deformed and sort of change that position or bounce back. You have softer materials like that, or you have on the right side, hard and brittle materials that instead of bending or smooshing at all, they just shatter, right? And so some metals, like a steel bar or aluminum can, you crush them and they just sort of bend and deform. Other metals and other materials are hard and brittle. And so glass is a classic example. Glass doesn't really bend, it just sort of shatters, right? And so things fall into that category. It's not quite fair unless you're talking about the similar materials, but it's definitely, this dynamic, even for steel, is something that for a long time, for centuries, sword makers have had to think about quite a bit. And actually the katana, if you really want to nerd out on one particular item, katanas are fascinating, the Japanese style swords, where they're hardened on one side and softened on the other side to make them springy, hard, and have a really sharp, maintained edge. And that's true more broadly about most swords that were made. The edges, the sharp cutting edges were hardened one way or the other. And then there's a softer, pliable center so that they can still flex and move a little bit. If you're buying, nowadays you're buying a sword to put up on the mantle, that may or may not be true, right? That, now people buy a sword not to be used as a weapon or a tool, hopefully, but to just have as like a thing to put up on the wall. And so that may not be true, but definitely when they were the prime tool of warfare, it was totally a thing that people had to think about in this dynamic. And if you're working with metals, it's something you may have to consider if you're trying to make your own different pieces. You may need to harden materials through a process where you take them up high temperatures really fast and then you cool them off very quickly so that you have very small grains within them, so that you get very small crystal structures inside the metal if you heat them up and then cool them off in oil. Or you can put them in an oven and sort of cook them at 200 some degrees for a long time, and they start to get a little bit softer again, which is a process called tempering. So hardness and tempering. Those are interesting dynamics to think about. We'll talk about them a little bit more next week. But this dynamic is really important. A good place where this comes up is if you're filing a metal, it hopefully is going to be soft and pliable. So if you're using a file on metal, you want to do that on something that's going to give. And the tool that's doing the filing needs to be harder, but it may also shatter. If you played with the metal lathe and you look at the end of those metal lathe tools, they have a little insert on the end. Those are carbide inserts that are exceptionally hard, but they're also very brittle. So if you drop the thing, the tool will be fine, but the cutting end will need replaced because they're exceptionally hard, but also very brittle. So you drop them on the concrete, they take too much of a shock and they all of a sudden just shatter. Or a router bit is a good example. They're hardened tools. If a router bit is going to break, they usually will just snap or shatter. And so hardened tools like that, you have to keep this sort of in mind. But steel is fascinating because we can slide it along that spectrum as much as we want, which is really cool. Just categorizing metals. While we're trying to identify, it's good to go through the names. We've got aluminum, which is a fan favorite. Used to be the most expensive metal you can get. The Washington Monument is capped with aluminum, in case you didn't know that, because at the time it was the most expensive. There's like an electrical process that has to be used to get it out of rock. And so that's what made it very expensive back in the day. Now it's super cheap all the time. And a machinist probably considers aluminum not even really a metal, because it's too, according to them, it's too soft and gummy. And I've definitely wrecked tools in aluminum. I wonder if it's still up here somewhere. But you can wreck an end mill by just having it scoop up too much aluminum, and it'll get gummed up in the tool, and then it's ruined, which is pretty frustrating. Brass is a really fun metal, and then there's bronze also, a golden colored alloy of copper and zinc mixed together. Copper is that reddish orange. It's in lots of pipes. We've been using copper for pipes for a long time, and it's a great material for that. Lead pipes, no one should be using anymore, but lead was originally used for plumbing. It's even gotten the Latin name on the periodic table, plumbum, for plumbing, although it's still not a good idea. We need to continue to not use that. Pewter is a really interesting metal. There were lots of toys that were made with it because it melts at a really approachable temperature. It is fairly toxic while it's still molten, so it's not, kids' toys shouldn't be made out of it anymore, but if you want to make jewelry, you're going to cover it up with paint. It's actually a pretty fun metal to work with. You just need to keep that toxicity in mind while you're handling it. Wash your hands, do all the safety things, but it is a neat material. Nickel is another one. It's slightly antimicrobial, which is really neat. It's hard, ductile. It's used in lots of coins. Titanium is a really hard metal. It's hard to use in some of our tools, like the lathe. You can turn titanium. You can make titanium things. I've seen titanium cut on a water jet before, but it's just got a little bit of a different properties. It always lands on the harder side of that scale. Zinc is a neat one. If you have a penny from, I think it's like 1982 or something and beyond, so almost every penny, and you cut it open with snips, which I suppose I probably shouldn't endorse, but you cut it open and inside most of the penny is going to be zinc. It's very cheap, but it also doesn't do very well on its own. Zinc, if you want to think about what zinc looks like, think about galvanized steel. It's that weird galvanization layer because zinc itself doesn't really rust, and so it can protect steel underneath if you coat something with a zinc layer on top. Which brings us into this like ferrous metal category, where if we're talking about our different metals, these are all the iron class of metals. So you've got iron itself, which is the most abundant thing on Earth. And then you've got steel, which is a low carbon metal. Usually it's pretty soft. This is the sort of thing that comes out of a steel mill. You get something like this. It's pretty workable. It's something that you can do a lot with. And then there's hardened steel, which is usually what gets used for tools. And so there's not a lot of difference there other than sort of the carbon content. There's different alloys that can be made. Stainless steel is, I think, 11% chromium. So you can get alloys mixed in where you have different metals blended together. And this can sound really strange, but these metals are usually pretty approachable to buy. Like you can get aluminum bars and rods at Home Depot or Lowe's. Copper pipes are very easy to get your hands on. There's other copper things that you can use. You can buy aluminum bricks. You can get different metals. And if you ever want to buy very specified metals, McMaster-Carr, and I should pull this up as just like let's see if I can just find a browser tab and pull up. We'll talk about McMaster-Carr many times throughout the course because it's a great source for things. It's also usually the most expensive of the sources for things. So here we go, pulling up McMaster-Carr. This supplier, you can buy all kinds of different materials, but one of them that's somewhere usually not too far from the top is like raw metals. So in here you can, we'll look at this at various different times in life, but in here you can buy raw materials where you're able to just buy blocks of steel or metal, or here's raw material metals. You can just buy whichever metal you can think of. They've got lots of different options. And then you can buy them in different sizes and shapes, different amounts. You can buy the rolls, bars, all sorts of different things to meet whatever specific needs you might have. This is, and actually one of their warehouses is in Strongsville, Ohio, right next to where I used to live. So, you know, that feels like I'm playing for the home team whenever I order from them. But that said, these are the materials that are really interesting. A lot of what happens in here, I think, falls into either the iron steel category or the aluminum category, but there's people who do metal work of all sorts of different types. So where would you buy these things. You can buy sheets, pipes, bars, blocks, tubes. Steel tube in the back is actually very approachable. It's a reasonable price. Sort of, it's right underneath where the metal or where the wood for sale was, and it's great that you don't have to transport it. There's also aluminum tube back there. So if you're interested in trying to work with aluminum, you can do that. They also sell sheets at home stores. Pipes and tubes are fun to play with, and you can get it at most hardware stores. There is one interesting thing to think about with this is there's also some suppliers, and I'll put links in Foundations for where you could buy. If you wanted to buy a large amount or you wanted to industrially purchase steel, you can totally get there. It is, according to the pandemic, it's a little harder to get a hold of a big raw piece of metal than it used to be, and that the price is a little higher. But it's still possible. Most of our projects are not going to be the amount of metal that it would take to build a washing machine, so it's going to be fine. We're not buying large amounts usually, so it should be okay for our purposes. Also, I would say that if you're thinking about a metal project, there's always a very healthy scrap metal pile in the back there, and it's fascinating to see what you can find. Like there's some pieces of brass over the past year I've seen, like big chunks of brass that are someone else's leftovers that could be very nice projects on their own, or big chunks of aluminum or steel or whatever. So it's totally worth taking a look at the scrap pile in the metal shop, and we'll absolutely go do that right after we're done. But there's tons of cool things that you can look at. You can buy, if you're looking for a particular thing, you can totally buy it. What's up? That is a good question. Some of the tools will be marked very clearly, like not for aluminum. And the grinding wheels are a good example. They'll gum up aluminum. They'll gum up if you put aluminum on them. And so you will need to be able to identify. The easiest way to identify is that steel is magnetic, and many of the other ones that pass through the shop are not. So you can usually put a magnet to it and have a pretty good guess that it's steel. Another great resource is a facilitator who will be able to help you guess that. But usually magnetism, not magnetism, is the easiest one. On the list, the things that are here, the only ones that are magnetic, oh, you're good, of these are just the ferrous metals that are listed. So stick a magnet to it and you'll know that it's iron. All the rest of them are a little trickier. If you want a fun high school chemistry project, we can absolutely find the density of these metals and then use that to identify them. It works really well. Just ask my teenagers. But in here, we're going to try and identify the tools that are in the metal shop and look at what they're for. And lots of these will give you an idea for getting badges. And so we're going to go through them sort of in categories. These are our cutting tools. And there's lots of them. There's lots of different tools in the metal shop for you to play around with and use. We've got chop saws, just like the chop saw in the wood shop. There's a chop saw in the metal shop like this. It is definitely more sparky. It's got clamps built right into it so that you can have that, or have your piece not move around on you. You can set angles. It's not quite like the double compound sliding miter saw of the wood shop, but it's similar in spirit. There's a drill press. So if you use the drill press in the wood shop, it's very much the same game. There's a little one and a big one. And that's because you may need to cut a very large hole. And so you might need a lot of torque or a lot more power. Or in theory, this floor standing one is if you have something very tall that you want to cut at the top of it. If you want to do cutting, you can also use the plasma cutter, which is this device right here. It's a fascinating way to just sort of blow through a metal. It's kind of like welding, but instead of trying to put things together, you're tearing them apart. There's these pneumatic tools across the bottom. And so this is like a little tiny jackhammer. This is a small cutting blade, like a tiny sawzall. And then we've got other pieces in here that are these pneumatic tools across the bottom. But I think my favorite of the cutting tools is the horizontal bandsaw. And it doesn't necessarily sound like it would be super exciting, but I will 100% recommend you get the horizontal bandsaw badge this week, because you put in a piece of stock and it will cut it off for you. And then it will automatically feed it forward until the next cut. And it can cut to the same size, a bunch of different pieces. And so it's really fun to just watch it do its cutting. And it just sort of robotically goes through it in a fun way that's fascinating. That was.
I was going to say very quickly about that one in particular.
Should be on, just right up to your chin. Yep.
So the horizontal bandsaw, so quick thing. My boyfriend's an industrial designer / engineer, and he helped me figure out how to use it in the space. I got badged on it. And from what he noticed, the way that it was used, he's pretty sure it was set up in a factory somewhere to just cut metal stock all day. And because it's like so automatic and set, you can set the settings to be so precise in how long the pieces are when it cuts it. It could just be fed stock, like long tubes of metal, like all day, and it'll just go. The one thing I will say about this is that it is possible to put too short of a piece in it, and it will not recognize that it's in there. I had that issue with the piece that I cut, and it was just kind of like, why isn't it working? Oh, because it's got this feature where if it doesn't detect a certain length, it won't turn on. And it's kind of a safety feature, kind of just like a part of the quirk of it.
Yeah.
I don't recommend doing this. I had to disable that feature in order to push it forward so it would cut. Don't recommend doing that at all. Just make sure your pieces aren't shorter than, like, I think my piece was shorter than 6 inches. So it's not for small things like that.
Right. No, but it is really good. Like if you're in the space, and while I've got the camera pointed this way, the tables that everybody's sitting at, all of their legs and all of that body, it's just a piece of plywood on top of tubing that was cut on the horizontal bandsaw. And so it's really kind of fun to see that those pieces, and I would need to do a lot. Let me stop the share just so that you can all see exactly what I'm talking about. Those tables right there, they were cut on the horizontal bandsaw. And so you can get all the legs exactly the same size just by putting a long tube on, and it does all the cutting for you. So everything works out just fine, which is real neat. Oh, now I need to get my share screen back. So back to this. Okay. So, and then that was okay. And so we've got all these metal cutting tools that are really lots of fun. This is a good category to be in. Most of the time, if you're going to do a project, you need to cut things and get them apart. And so metal, because it usually will come in some weird shape, cutting it down is a good way to go. Other ones that aren't shown here, but a good category is the vertical bandsaw. The vertical bandsaw is a little different than the wood one. The wood one's great for just any piece of wood. You can put it in there and they're pretty safe to use. The vertical bandsaw in the metal shop needs to have at least 3 teeth engaged with the piece of metal. Otherwise, it'll be too thin and floppy, and it can be a safety hazard. So you'll definitely need to think about that a little bit as you're doing things. There's other cutting pieces that are interesting to look at, like the shear, press, break, and slip roll. It's essentially, this is like it's a very easy it might just be a video and a quiz on the shear, break, and roll, actually, without even a checkout. But that one is just like a giant heavy duty pair of scissors. It'll cut through, I think it's 22 gauge steel. And oddly, in the American system, higher the gauge number, the smaller it is. So 22, 24, 26, higher gauge number steels, the thinner stuff, and it'll cut right through it. Or it can help you roll it, or it can help you bend it. So it's a really neat one. It's nice and approachable. It's also hand powered, not machine powered, not electrical or pneumatic. So it's very hard to get hurt on that one. So that's a good one. Angle grinders are lots of fun. They're good for shaping things. They can be useful. But we have lots of other tools. So if you want to grind or shape a metal, instead of just cutting it, you want to bend it, change its shape, deform it in some way. In wood, that's really hard to do. Wood doesn't like being bent. You have to steam it, heat it up, do other weird things to it. But metals do that fairly well. And so it's a neat difference. And this can actually, one of the people in last year's class was a metal jeweler, and she would make delicate, beautiful pieces of metal jewelry by bending and shaping. She made things that looked like flowers and all sorts of stuff out of sheets of metal. And she could do that tempering also to get colors and shapes out of the metals that she was working. But in here, you'll have, there's sort of like a sander here, or these bench grinders. A bench grinder like this was always present in every garage I walked into in the Midwest, usually just for sharpening your lawnmower blades. That's what they were often there for. But these sorts of things can be really helpful. They do come with grinding wheels. There's buffing wheels and wire wheels. Those can be swapped out, but they can give you different finishes on your metals. So if you want to try and get a shiny metal, you can head in that direction. There's lots of these different sanding options. There's a large belt sander. There's a small belt sander. This is the break and bender. There's also these like little, this machine is a bit tricky, and I need to, that's the shrinker stretcher. So it'll actually pinch on a metal to give it a curve in a way that's really predictable. And if you're trying to build your own car bodies, I suppose, you might want to bend sheet metal that way. I don't know why you'd be doing that here, but it could be fun. And so you can build your own pieces out of sheet metal. Here's an English wheel, which is another classic way to sort of manufacture your own sheet metal goods for bodies of things. And you can do some really interesting stuff. It's just basically a large press where you squeeze the metal between two wheels and you get interesting shapes by that rolling process. The badging video for that is fascinating. And then this is an arbor press. So an arbor press is sort of a weird thing. It's got this big heavy wheel and a large gear. You got to definitely watch out. It will absolutely pinch your finger off. So be careful with that. But it can apply a very large amount of force to a metal, much, much larger than you would ever be able to apply yourself. So it's a really neat tool for that. There's all sorts of interesting ways to bend metals. And if you're ever curious or stuck or really confused about how to get a certain bend, it's definitely worth it to take a look. We're good. You can come on through. If you have some metals that you'd like to bring together, there's lots of different ways that you can do that. You can join metals with screws. Screws are easily a great way to do that. You may have used screws in your current woodworking project or in a previous woodworking project, and notice that the teeth for those, the threads for those are pretty big. You want to have some space between it so the wood can be nice and strong and held on, but machine screws have very tiny teeth. You can get a lot more hardness out of the wood, so the teeth can be much smaller. By teeth, I mean the thread. The thread in here can be much, much smaller. This thread has been specified for a very long time. It's been a standard that somehow magically has spread globally. Very early on, since machine tools were first made in the 1700s, the thread standard became a standard very, very quickly. And so they're fascinating things. There's whole diagrams about them. But there's screws like this. There's machine screws. There's nuts and bolts. There's lots of interesting ways to distinguish that. Other interesting ways to join metals are rivets. So if you drill a hole, you can put a rivet through things. And so they're a really interesting way. These are rivets right here. You pass a rivet through two sheets, through a hole that you've drilled in two sheets. And then you press it so that it's up flush against this piece right here. And then you do a pull, and this sort of button on the end gets pulled towards the sheet metal, and it just sort of deforms and squishes the two together in a way that they can't come apart. That is usually how the sides of big metal boats are put together, is with rivets. And so you can make a fully watertight joint with that. It works great. It's a well-practiced thing around the world. There's also weird other rivets you can get that have threads inside them. So if you want to put threaded nuts and bolts into very thin materials, you can get threaded rivets that do a nice job with that. There's all sorts of different ways that you can do that. The more like industrial thinking about it ways that you might join metal, if you weren't satisfied with any of those, is the welding, brazing, soldering sorts of methods. And so we've got a person here welding. Welding is a ton of fun. You should absolutely all also get your welding badge over the next week or two. It feels really, really cool to just put metal together with some more molten metal. Other good strategies are soldering or sweating in a copper pipe, like you can see down here. And then there's brazing. And we're going to talk about sort of the difference between those three. The SparkNotes version is that welding, everything melts. And for soldering and brazing, just the sort of the metal glue melts. But there's a little more nuance to that. But those three processes are also really cool. Getting the MIG welding badge is probably the easiest of the welding badges, the most approachable type of welding to do. So that's a ton of fun. But a good question to ask is, what is a machinist? And in the Midwest, this is, everybody knows somebody who's a machinist. But around here, I don't know if that's really true. A machinist is a special type of, is a type of career, and just about every unit that we cover in here is a whole career. But a machinist is a person who can make things to specification. I have a buddy back in Cleveland who's a machinist that makes things for fighter jet parts. And he can produce things to within a certain specified tolerance, and machinists must be able to do that to a certain level of quality. And actually, like a professional machinist who's making military grade parts, their pieces have to be to spec, otherwise it's a felony. Like, it's actually fascinating how good machinists can be at making things and how high that bar can be for a professional machinist. Here, we're usually just sort of playing with things. We can get into that ballpark, but a machinist really has a deep well of skills at their disposal. And so if we try and think about what are sort of the machinist tools beyond the tools that we've described, we've got the metal lathe is the king of all tools. The first high precision tool that was ever made was a metal lathe. And then from a metal lathe, you can start to make all the other different tools. The metal lathe and the Bridgeport mill is, and so a lathe is for spinning a piece of metal. And when you spin the piece of metal, you can cut away from it. So you make round things on a lathe, usually, and then you can make square things on a mill. They're similar in spirit, sort of a lathe spins the piece of material that you're cutting, whereas the mill spins a tool and then cuts through the material. So one of them has the spinning tool, one of them has a spinning material, but otherwise they're pretty similar. But they're both very aggressive machines. I really enjoy using the lathe. However, I do want to say that those two tools in particular have day-long trainings that have an additional cost with a certified instructor. And it's a big deal because a metal lathe, as interesting as it is, and I want to use ours soon. I have a piece that I need to really put into a true round, but they, like a metal lathe, if the wrong thing happens, it can put a wrench through a brick wall, and it can put a wrench through you and not even slow the wrench down. So there is a little bit that needs to be thought about with this. However, there's lots of other tools that aren't quite as high stakes that are a great place to get started. And so they're really, really empowering tools. You can do a lot with them, but you need to be careful. A tap and die set is a nice one that can be run by hand that still falls into the machinist tool category. And so that's really nice. The metal CNC, which is this thing here, is sort of a similar friend to, we have the Gerber and the Shifoko. So it's very much the same thing. It just works entirely in metal. It's very much like the mill. There's tons of interesting things to go along with that. And actually it's much, much safer because everything happens inside of a box. It's sort of only able to go so big. We don't have the world's biggest mill, so you're not going to have pieces flying or anything like that. It's actually a fairly safe machine to use if you're already good at the CNC things, and we'll get better at it as the year goes on. There's an end mill sharpener, so if you're using a lot of end mills, you can sharpen those tools. And then this thing down at the bottom doesn't quite look like a tool. It looks like a table, but that is a surface plate. And so one of the things that's really hard to do is to reference materials and to measure really well. A surface plate is a special piece of material that is completely flat or flat to some specified dimension. So if you want to make something else very, very flat, a surface plate is the way to do it. And so you can use these for measuring things really accurately. You can use them to get flat materials. Surface plates are really fascinating tools in and of themselves, but they're a high precision tool, which feels kind of weird for just a slab of marble. But it's a really cool one. And then let's see, in here, there's also other tools that I think are perhaps more approachable than the lathe and the mill. Are jeweler's tools, or sort of like hand working metal tools, where you can talk about an anvil where you might use it with a hammer. You've got saws, like even little coping saws to cut through thin sheet metal. You can file things, you can hammer, you can saw through metals. A hacksaw can get you a long way in the metal shop for sure. You can forge or melt metals with a blowtorch or with a oxyacetylene torch. The English wheel is fun. Files really work well. And then if you wanted to get better at these things, there's lots of different ways that you can do it. If you wanted to work metal by melting something down and then casting it, you can totally do that with just some sand in a bucket. It needs to be a special kind of sand for things to not go weird. But with a torch, a little forge maybe, and some sand in a container, you can do a lot of really interesting things. You can make jewelry. There was a Make Haven member who came in, and she teaches kids how to make rings out of just molten brass, I think she's using. And so there's all sorts of cool potential for using lots of different tools at very approachable levels. I think she's doing that with middle schoolers. Everybody can do it. If a middle schooler can pull it off. What's that? That is a great question. We have four total or four new facilitators in the metal shop. And I don't know all of them very well, but I do remember hearing that at least one of them does jewelry. And so I think that if you message, we're going to message the group of them to like, I message the facilitators to let them know that we're coming. And so we'll try and figure out who's the jewelry one, which is really cool to see that opportunity and to get to lean on that experience. If that's a field you want to get into, it's lots of fun. Let's see. And so more broadly speaking about working with metal, metals in general, if we're sort of circling back, we talked about the tools a little bit. Metals, the material, they are polycrystalline solids, which doesn't necessarily mean a lot, but it does give a few of these weird properties. Cutting a metal is cutting a metallic internal bond. If you cut metals, instead of cutting wood where you'd have sort of sharp edges, metals usually will leave a burr on the end. So you'll have something that's very sharp. If you've ever built a computer case, especially early ones, they weren't usually deburred. So the metal might cut you. You need to be careful with that for things that you have just made in the metal shop. Their edges are often very sharp, and usually just touching them with a file, going a nice pass over all the sharp edges with a file can really go a long way to keep your fingers from bleeding. Whenever you cut metal, it's a high friction event. These are some carbide inserts down here, cutting in a GIF loop, some metal off of here. And so it's really neat to see those carbide inserts do their cutting. Carbide is harder than the metal, so it's able to do that cutting well. And you can see those chips coming off. These chips should be, in theory, where the heat comes away from the metal. If you ever look at a weld really closely, there's usually a little heat affected zone, an area that's slightly discolored. Ideally, when you're making a cut on a machine, all of the heat affected zone leaves with the chips. And so when we look at sawdust, sometimes you can think about it in a lot of the time, it's just sort of annoying and in the way. When we get to doing CNC work in the wood shop, we'll start to talk about the chips more. And in the metal shop, thinking about your metal chips is going to be really useful. They're usually very hot right after you cut them. And that's a good thing. You want the heat to go away with what you've cut off instead of staying in the piece, because metals also change their size when they get warmer and colder. And that's true for everything, but metals do it very, very much more than other things. So you can have a lot of expansion and contraction. So managing heat in these cuts can be really important. As we're talking about cutting things and how these chips happen and what goes on here, we're going to definitely need to think a little bit more strongly about personal safety in the metal shop. It can be a fascinating place to do all sorts of really cool stuff. But as we're walking in there, we'll definitely want to make sure that we have goggles on so that flying metal chips aren't a thing. There's lots of different tools that are buddy tools in the metal shop. We have this sort of TV that's here that as Mara walks in, you're able to see that they're in there walking around. That's just so that people can see into the metal shop with an uninterrupted view. It does have like a 2 or 3 second delay, but they're in there doing their thing. But a buddy tool, really, you'd want to be in the space so you can have clear eye shot to the person. Another thing that's really important in the metal shop is to always know where the emergency shutoff is for whatever tool you're running. I've had very old tools, like I had a jigsaw from the 1940s, and that jigsaw had a lock-on feature. That's a terrible plan. In the metal shop, you always want to know how to turn it off. None of our machines have a lock-on feature. They all have emergency shutoff buttons. And so you definitely want to know where that is before you turn it on. Another thing that's really important is no long hanging sleeves, hair, or whatever. Also, probably you want a cotton-based outfit or a cotton or leather, not a synthetic. A lot of the high heat things will just sort of melt their way right through the synthetics. whereas cotton, it'll bounce off of you instead of stick and melt its way into the garment. Also, you want to, it's sort of paradoxical, but don't wear gloves for most things in the metal shop. And that's, Jimmy Fallon knows why not to do that, but it's, you can have problems where if the glove gets grabbed, you can have it start to pull on you, and there's a lot of geometry in a glove. So if the glove gets grabbed, it's going to start to pull on your hand and move your hand really into something, which doesn't sound that bad. But if you just barely touch something with your finger, you'll know instantly. If the glove just barely touches, you may not know right away. And so that can be a very big problem. And 0% do we want anyone to get injured at all. But it's actually safer if your skin is exposed and you can see and feel the end of where it is. And the only exceptions to that are for welding, where it's just too hot of a metal, too hot of a material, and you absolutely want to have protection from little bits that come flying around. Another thing that's really important is to clamp down your work pieces. In the wood shop, you should clamp everything. And sometimes, truthfully, I am not as good about that as I should be. In the metal shop, I always clamp things down, because all of these tools with cutting metal are higher torque, higher power, and you need to be more careful and cautious about what could happen if it doesn't go to plan. And so clamping so that you're not holding a piece of metal in place is really important, because if the drill press grabs it and it starts to spin, it's going to be spinning into your hand as opposed to spinning into a clamp. And then, you know, if the clamp gets slightly damaged, it's no big deal. But your hand, you've only got 2 of them. So we want to keep them nice. Knowing how the shutoff works is really important, and non-synthetic clothes. Okay, cool. The next pieces that are really fascinating is that measuring is actually kind of hard. And being one who teaches high school, I literally gave a test on this on Friday, and measuring is not as easy as you think. Even if you think you're good at it, we all can get better. I had physics 302, which was essentially like the physics of measuring things. It's totally worth its own entire college class. So using a standardized measuring system, thinking about the 0 point of your measuring tool is really important. Knowing where both ends are at the same time sounds kind of silly, but it's useful to do. Comparing the tool with the thing being measured, and then how much uncertainty or how much wiggle are you allowing for your part can be really important. If you take the lathe class, one of your objectives during the class will be to make a part that is a certain size, that is 1.25 inches in diameter. And so your goal will be to be 1.25 inches within, you know, a 10,000th of an inch, so that you're very specifically 1.25 inches. And so machinists will often need to think about that. That's the sort of thing that is the felony for my machinist friend. If you say it's 1.25 inches to a 10,000th of an inch, and it's not to a 10,000th of an inch, even if it still looks like 1.25 inches, you're out of spec, and that's a problem. So that's the sort of thing where most of our projects over the next 2 weeks are probably not going to hit that level of precision, but there's some really important details if you want to measure things really, really accurately in the metal shop. Whereas in the wood shop, because of wood movement, that level of precision just can't happen. The wood is going to expand and contract up to 8%. And that's a lot of movement. Whereas a metal is going to stay basically the same size, except heating and cooling, which happens very predictably. So hitting measurements is really important. With that, a good set of calipers can be your best friend. And if you haven't played around with these, you totally should this week. You get 3 different types of measurement. On these bigger clamps, the bigger claws, you can measure the width between them. And these smaller ones, that's for measuring inner diameter, so inside of a pipe. And then there's this one on the end that's for measuring depth. All 3 are measuring at the same exact time, and there's different levels of measuring tools. I have some that I carry around all the time. I wonder if I've actually got them in my bag or not. But these I usually carry around with me. And whoops. And so in here, you can have measuring tools like these. Mine have no dial on the front. There's ones that come with a dial like that. And most people really like to get started with the digital readout ones so that you get a nice, easy, clean reading right off of it digitally. But at different levels of precision, you may want different tools. I like these because I nerd out on measuring tools. But those sorts of different tools can be really helpful if you're trying to hit exactly the right thing. Also, I'll post a link to these slides. But in there, there's a video on how exactly to use these if you'd like just a quick refresher or overview on how they work. Or we can absolutely use some if we're in the space together. It's not a long push to get me to measure something. So starter metal projects. What we're going to talk about this week is sort of how to get you going. We're not necessarily starting a project this week, but just thinking about what could be good projects to do. Good starter projects could be your first weld, or maybe like you weld your name into a bar of metal, or you weld a friend's name and give it as a gift, right? It's kind of a fun thing just to be able to lay down a bead of weld, and it's definitely a skill that you get better at with practice. So you can play around with that and just have some fun welding projects be a good first project. Sheet metal cutting and bending can be really neat. If you're already good at 3D design, there are 3D design softwares that will help you design and plan 3D bends or metal bends based on the bending properties of those metals. So there's some really cool stuff that happens in there. And if you want examples, I've got a few. And a good example is if you know how to do sheet metal bending in design, you can also try and use it for plastics and other things. Another one that's good is use a saw and a file to shape things, to make little metal structures, little metal designs. It's actually pretty approachable to use a file and really make a little tiny metal sculpture. It's totally possible to do. And it makes for a really pronounced effect. You can get some, there's different materials to change the surface color a little bit of metals so that you can have a blackening. So deep crevices look dark. Think of like class rings for high schoolers that have the dark color inside, or like the darker features inside of a ring. You can have a blackening feature there. We have one of the facilitators I've seen make a knife from scratch, which is a really crazy thing. Daryl will be able to make a knife with you if you wanted to do that. It is not the fastest procedure. It's definitely a cool one though. So it's got lots of fun, and we do have a forge, a little oven where you can cook things. And so there's lots of fun to be had in there. Also, if you're interested in working glass in that little forge, Kate is really good at melting wine bottles and turning them into spoon holders. So if you wanted to do that, that's a fun project. Kate's all about the glass, and so she can help you out with that. I think she has a pre-programmed temperature profile. Does that feel right?
Yeah, that sounds like something.
Yeah, it sounds like something she would do. So you put a wine bottle in, you follow Kate's program, and it just does it for you, which is really good. Although you want to talk to her to make sure that goes well. Another really good starter project is to make wind chimes from pipe. And that may sound like it's not the craziest project, but there's some details in there that make it a little tricky. How do you hold a round thing and drill a hole through it? How do you mount them? How do you connect them together? What sizes and lengths do you want them to be to hit the notes? If you're good at measuring your lengths, you can hit exact pitches on a copper pipe. Which is really cool. So you can have a perfect harmony across your wind chimes instead of just random notes. There's all sorts of things. You could weld a table base. Maybe you made a cutting board and realized it's too big and you want a side table instead. You could cut some steel tube and make yourself a side table to use this week with what you did last week. You can clean and polish metal parts, and then spot welding is a lot of fun to make a little metal box. So spot welding is a cool process. What's up? Yeah.
On the badge list, like there's 3 different types of welding.
There totally are. There's the MIG welding, oxyacetylene, and then what's the third one? I'm blanking. TIG. Yeah, MIG and TIG are pretty approachable. I think it's the MIG one that's the one that most people will do first. Yeah, and so I would stick to the MIG welding. The other ones are a little bit trickier. Not and MIG and TIG I'd say are pretty similar. Yeah. The one that's not stick welding, that's the one that you want to do. Is it MIG stick welding? Did I get them backwards? I do mix those up. Yeah, MIG stick welding and oxyacetylene. So MIG welding is where it feeds the filler material in from the gun. It's a lot less things for you to have to think about all at once. Stick welding is when you're applying heat and then in your other hand, you're applying the filler metal. And so it's 2 things at the same time, which is not terrible. And you can do anywhere without a big welder machine. We have a big welder machine, so it's easier to do. And then oxyacetylene, you can actually weld without even needing to add filler material. but that is its own like kind of art. You have to take solid metal and make it molten, and then it's definitely the more advanced of the processes. I would recommend that everybody tries the MIG without the stick. That's the recommendation for the week. If you're already good at that, definitely try another one, but it's the way to go. The oxyacetylene you can also use to cut metal. If you're really on it and you want to do some of that, you can cut through things with that torch. But if you're trying to think about projects and you're thinking about some of these sort of for the long term over the 2 weeks, and you can totally think up other assignments. One of the things that I'm going to post a link to is this grab bag assignments piece, and it will slowly load as the internet comes into being. But this is a document that I'm trying to put together so that there's a reasonable set of suggestions all the time. Ooh, and let's zoom in on this a little bit more. We want to go to fit. And so in here, if we're talking about the intro to metalworking, week 1, I'd say just get the badges. And week 2, here are some like pretty on point projects. So if you wanted to try building a side table or wind chimes, or this copper wind charm, which is sort of a similar thing, these are all things that we have some experience doing. We've done, I have not made the wind charm. It looked pretty doable though. But all of these are things that we have experienced, we think would fit pretty neatly into the 10-hour mark. So if you wanted to try and get everything buttoned up within the time frame, you can absolutely go for that. A cool one to try in week 2 is, especially if you have experience with the laser or vinyl cutter, is to cut anything on the water jet. We're going to nerd out about the water jet. It's my other favorite machine in the metal shop. The horizontal bandsaw and the water jet, they just like make me happy. But those we'll take a look at. Those are in the grab bag assignments. I'll put a link to that in the foundations chat. One good thing to think about is dog fooding. And so within Makehaven, we do a lot of this. If you're not familiar with this term, it's a good one. It's from the phrase or the idiom that company eats their own dog food. And a great example is Facebook, who does a lot of eating their own dog food. They built their own infrastructure. And then last week, when everything went down, it was because they built the systems, everything was sort of interdependent, and then it shut everything down all at once, which is fascinating. Not always the best strategy, but it's really helpful here in Makehaven because we can use the metal shop to build things that Makehaven needs. And that's often really true. And so using all of these tools to build other tools that you need can be really helpful. Like, for example, if I ever come to a realization that I have to leave New Haven, leave Makehaven, the first thing I'm going to do is start building metal clamps so that I have wood clamps to take with me when I leave, right? Building your own tools can be kind of silly, but it can also be really, really useful. And so doing that sort of thing can be something that's helpful if you're looking for inspiration for what to do. What's something around you that you might need, and how can you build something that works in that regard? And so over the next week, we're gonna circle back to these things, and we're gonna definitely take a look at all of these projects a little bit more. But we're gonna cover more in-depth soldering, brazing, welding. We're gonna talk about tempering and sort of what you do if you wanted to make a knife from scratch, how you harden it and then soften it again. Some of the lathe and milling basics, giving an overview of what CNC is, because we're going to circle back to that many, many times. And then we'll talk about the water jet. Also, some of the more esoteric metalworking processes like electroplating and sort of the process of how welding can happen. And that is often helpful to do a little bit of welding before that so that you can get a sense of how that fits together. Electroplating is a fun one where you can make the surface of different metals look other ways. There's lots of cool tricks that you can do with that. And so you can make all sorts of fun different effects on the surfaces of your metals. But your specific goals for this week. Oh, you have a question? Yeah. The lathe and milling classes run, they run like monthly because it's one guy named Chris. He's very nice. And he's a teacher at a technical school, and they do them monthly and alternating months. I would need to look at the schedule. I don't know if it's going to happen during our 2 weeks. I'm interested either way. Yeah. Absolutely. And it's there's usually like 4 people in those classes. There's a limit. And it does have a price. So it's like I think it's $150, but it's fun. I did it. It's totally worth it. I paid for it, and you know, the the usefulness of those tools is really good. And it is sort of it's a precursor if you're trying to learn how to use the CNC machine. Some people will really feel better about using a CNC by using the Bridgeport first, because it's got sort of the manual dials and knobs that the CNC automates. That's not true for not everybody needs to learn it that way, but some people really like to be able to sort of manually do what the robot's going to do for them in the future. And so if that's the way that you like to learn, doing the Bridgeport class can be really helpful.
So there's none on the schedule as far as I can see, but that doesn't mean there isn't going to be some on the schedule.
We'll talk to Kate and Ashley and get back to you within 24 hours. Absolutely. So yeah, those are the things for that is broadly speaking what's up. It's definitely fun to play around. The facilitators can all show you those machines. So if you want to like see one of those machines operate, which I think has value in and of itself, you can totally do that. And then there's, I don't know, I love the YouTube channel, This Old Tony, which is just a guy who's pretty tongue-in-cheek humor. He does a lot of machining. So you can watch those machines run. It's fairly mesmerizing. There's actually a ton of those on YouTube. That's just the one that I watch the most. And so your goal for this week is just to get some of these badges, to get yourself headed in that direction. And the MIG welding badge, the horizontal bandsaw, and the metal angle grinder, I think will get you a long way if you were to just get those three. There's a fair amount in the metal shop that are either watch a video and take the quiz and you're good, or they're super quick checkouts of like, can you turn it on? Do you know how to shut it off on its really quickly? Those checkouts can be really, really fast. And we freshly have, I think, 4 facilitators, maybe 5 facilitators. And Mara is in the metal shop right now. She's one of them. And we have people, I looked at their schedules throughout the week, and it looks like, and I think actually I have it pulled up on one of these tabs, perhaps, if I zoom out of here. The facilitator schedule, we have a few people across the board. Here's Mara, and then we have Alex is going to be in tomorrow, as well as Alana, who I haven't met, but looks like she's got lots of things under her belt, and might be maybe the jeweler, although I'm not sure. Coleman, who is really good at lots of things, can help you out in the metal shop as well on Wednesday. And then Daryl, who made the knives, is going to be in on Thursday. And then it might be more of a weekday game for scrolling through all of our facilitators. I think that they're mostly here on weekdays, which can be a little dicey, but we can walk in and talk tomorrow right now. So there's all sorts of fun people around to meet. And then also you want to think about sort of the badging. There's also a fair amount of tools like the files and saws and some of those things you don't need badges for. So if you're trying to build the wind chimes, you may not even need badges to use some of those hand tools. So there's lots of opportunity to be successful in a variety of ways. And it's definitely going to be exciting to see what sort of things come out of there. One thing that is important to keep in mind here, the woodworking, you might have noticed, ran a little slower than you might have imagined as edited on YouTube. The metalworking shop, I would say take that and dial it up just a little bit more. It's not because the cuts themselves take any longer, really, but because getting things tuned in to how you want, because usually there's more clamping involved. There's a bit more, if you're going for more precision, you'll want to think about all those details. And so you want to think about it very carefully, how much you want to dedicate your time. So don't take on necessarily the largest project in the world, but making a fun one a neat one can be fun. You can do like a little sheet metal box. There's lots of those that are interesting little pieces that you can use, where you could design a thing that's folded and cut and then spot weld it together or use a few rivets. You can make some really neat things elegantly without using all of the different tools. Whereas in the wood shop, you kind of need the large collection of badges altogether. The metal shop can be a little bit more one at a time, get the badges that you need as you go for each project. So yeah, those are the slides for the day. And any questions, thoughts, or concerns before we head on to what I think is going to be very exciting, the show and tell? Really looking forward to seeing what people made or are making, which is totally valid. Let's see. All right, and then people who are remote, let me stop the screen share just to pop in and see if anybody who's remote is saying things. No, we got a few people. All right, awesome. So what we're gonna do now is we can do the show and tell. And so I'm going to make a few setups on our end so that we can come around, pass around the microphone and have people show off all the fun stuff that they made. We can do this. If you wanted to walk up and get closer, I'm going to change it so that this camera up here in front is the one that is on view. So now we're here, and then I've got the microphone to pass around. If you and what you can do is talk. You can walk up to this and show off your piece. If you want me to walk up and show off your piece, I can totally Vanna White for you. If you and whatever works best. Lisa, you want to go first? Yeah, sure can.
Okay, so it's not nearly done. I don't know when it's going to get done, but it is a footstool, like a very low angled one, so that when I'm sitting in a regular chair, my feet are more comfortable. So these are the vertical pieces that it's going to sit on. They're cut, they're identical now. And I'm just keeping them stuck together in case there's anything else I can benefit from doing while they're stuck together. And this is the board that the feet would go on, and I haven't cut off the ends yet, so I just let that stay. I'm just trying to, get it smooth right now. But then the next step is I got to turn a dowel, which will connect the two legs together, and then drill a hole and stick it through the legs, and then aim where to cut square holes to poke these through. So that's where I'm at.
Cool. Yeah. All right. And then let's.
Yeah, cool. I actually have a process pictures on my website, but
Oh, do you want me to pull up your website?
if you can, that'd be easy.
Yeah, I can.
It might take a second though. Somebody else want to go?
Yeah.
Go ahead.
Pass it.
Cool. So I originally planned to make a huge charcuterie board and then made the mistake. So this is my failure for the week. I haven't put pictures on my website, but my failure that I figured out is I forgot about the kerf. So my huge charcuterie board turned into a little charcuterie tray. But imagine avocado toast sitting on top of it, and I think it works out pretty well. So it's all from scrap. It's a little hard to see because the color difference is not very big, but it's little strips that I glued together. Jointed, planed, used the bandsaw to cut out the handle piece of it. Sanded it so it's pretty smooth all over the place, and then hopefully there will be food on this at some point, so just finished it with some mineral oil.
All right. Yep. Keep going. My computer's running real slow. Me pulling up websites may not work today.
All right, so I made a gigantic, very slabby, I think cherry cutting board. It was rough sawn lumber that was in the back that I squared and turned into this, and I'm super happy with it. During this sanding, it got really cloudy and terrible looking, and I was like, oh no, and then I put beeswax and mineral oil on it, and it turned gorgeous. So yeah, that's it.
Yeah, very nice. Yeah, that's you're good. If you want to go for it.
Yes. Well, I did pretty much the same as last week, but I did it I think better, bigger, more precise. paint it. And, like, I'm feeling more confident now using them, all the tools, all the machines. And I'm happy because today I know something more than last week. So this is my project now. I think I can put even more stuff here, like sunglasses, maybe a little book, like more functional. So that's it. Yes, it's just that one. Yes, and I like how rough it looks. I didn't want to use the planner for this piece because I didn't want to lose all those. And no, Corey and I did it today. I used all the drills and and I think it's pretty like really it's gonna hold like good weight.
It,
So,
it was a fun experience with the drill press, right?
yes, yes. So this is it. It is plywood. Yes, it is. Yes.
It it was a delicate affair for sure.
Yes.
The whole I was very impressed the whole time I was holding my breath. And was glad you could only see half my face for that.
Yeah.
So you didn't know how nervous I was.
Yeah. So this is it, guys. Thank you.
Yeah.
So,
Worked out great. And then Arvia, you wanna yeah, you can just say hi and
Hey y'all, I was away last week, so I didn't get to do all the things, but I plan on I started drawing out a little kind of rough, ugly drawing of a hand mirror that I'm going to make in there. So I wanted to be like asymmetrical. Yeah, and I'm gonna follow like doing the cutting boards and figure out how to do the concave to put the mirror in. I've done some in the past and I actually cut mirror on the water jet in there, which is really, really cool. So if you're interested in that, it's really dope. So I might cut a small mirror to put inside the wood hand mirror that I make in there. So yeah, just catching up. That's the plan.
cool. Yeah, that'd be a fun way to integrate the two shops. So I'm real sad. The internet is just not working well for me.
yeah, no, that's all right. So I started with one of the big slab of woods in the back. I wanted to do a dice tray because the dice tray I currently had is this guy, and it kind of is like not that fun. So I wanted to make my own. So started with that jointer, planer, all that stuff. And I 3D modeled this first, which helped a lot to see what I needed to do. And then I have 2 joints with miter joints, and then 2 with box joints, which was so annoying to cut. Thanks to Corey. It was like just a bunch of passes on the saw stop, so annoying. But it worked out. And then the bottom is just kind of grooves, and I just cut so it's grooves all around, and I cut a plywood to size, just kind of put it all in, glued it together, cut this divider, and then stained it all. There's leather that I laid down, which should have been apparently the last step because now there's stain all over it after I've stained it, but that's fine. It's not like it was expensive or anything, leather. But yeah, it works. Here's my dice and I can roll it. It's fun. And I did roll 2 dice on this. The first one was a natural 20. The second one was a natural 1. So I don't know what it tells me, but so here it is. I'm excited about it. Well, I'll
Yeah.
figure it out.
Oh, that's it. So what do we use for 3D modeling for anybody who didn't hear? And for me, it's usually Fusion 360, but Sinem was using SolidWorks, right? And so all of those are available. I do believe that all members get a free SolidWorks license, which is kind of wild. So if you wanted to do that, I'm going to stick to my Fusion 360 land because sort of like Windows or Mac, once you get used to one, you want to stay. And I like that Fusion 360 has a full CAM software to go along with CAD. So you can design and then also plan the cuts to make something all in one spot. Fusion 360 and SolidWorks are sort of the two big companies that live on its side. There's other options you can do. I would really love to endorse FreeCAD, which would be like the Inkscape versus Illustrator, the free version that's open source. It's just not quite there yet. So I'm still until, you know, if that comes into maturity, I'll try and make the switch. But for the time being, I'm a Fusion 360. Yeah. And so we've got a few people who are online who might be able to share with us what you've been up to. We'd love to let you do it. And so right now, just pulling up who I've got Norm with your camera on. Would you be willing to share with us what you were up to this week? And while you get, it takes a little time to get all of those things adjusted. So while you're doing that, Seenam, can I grab your thing and put it closer to the camera? We can do this for everybody. So we'll just sort of do this for people. We'll grab them and sort of show them off. So in here, get a closer look. Here's all the dice. You can see the spider joint. When you put it real close to the camera, it's always, you know, there's a box joint, right? So there's a fun box joint. All right, Norm, it looks like you're good to go.
It's probably easiest for me to screen share, but it's disabled. Can you turn that on?
Oh, yep, I sure can. It definitely takes, let's see, hopefully it's turned on. Try it now. Let's see if you can get to it.
Is that showing?
Yep, it's showing.
So last week I cut a branch of a tree and then wanted to figure out how to use a lathe. So last week I got it cylindrical and figured out how to design it. And then this week was more trying to figure out how to do a bowl, because the idea was that eventually I'd like to do bowls. And I started, a couple people suggested having a wide drill bit start taking out some of the wood that you need. And I tried that. For me, that wasn't the very best. So I got a U-shaped gouging tool, which then did to my mind, a much nicer job at reaming out the center. And I'll probably cut it off part of the way to make a small bowl that might hold nuts or something, smooth it up. But eventually I want to make nicer bowls now that I have some sense of how to do it. So the big thing this week was really getting the bowl shape done.
Cool. Yeah, it definitely, making bowls is totally an art. And so just getting started with it is a ton of work. And so the fact that you're headed down that road, you've got the right tools, the right skills to get going in that direction is real exciting. I'm excited to see sort of how you'll develop as you do that more and more. So great work this week.
Not sure how to turn off screen sharing.
Oh yeah, let's see. View options.
Oh wait, I see. Wait,
yep, I think we got it. Cool. All right, and then let's see. Vincent, you're next up on the thing. If you're around, we'd love it if you could share at all with what you've been up to.
Sure. Can you hear me okay?
Yep, we can hear you.
Okay, wonderful. Screen. There we go. Can you see everything on my screen?
Ooh, yeah. A table.
Okay, cool. So this is the documentation that I rushed through, so there might be some typos. But I ended up making like a step stool mini table thing for my rabbit to get in and out of the litter box more easily. Rabbits are not supposed to be using cages, even as litter boxes, but that's what I had. So that's what I was that's why I made the step stool, to compensate for the difficulty of getting in and out of one. It was originally supposed to have a ramp on the side where he'd climb up on the ramp, and then there would be a little landing spot here, and then he'd just be able to go straight in, as opposed to jumping in and out directly at an angle, which probably isn't good for his joints. But to make it simpler, for now, I was going to do just the stool and then add the ramp on later. I designed it with a ramp where it was directly attached, but what I want to do next would be make it so the angle can be adjustable. So that way it can compensate for if I don't have the height quite right, or if the floor is not level, like I have part of it on the floor, part of it on a carpet, then it still works out. So I'm leaving that part off. One of the other changes that I had made was I decided to use mortise and tenon joinery to attach this apron to the side, to the legs. That ended up making me have to change the design. And you'll see later that there was a mistake that made it, so I didn't get to finish all of this, but I got the panel done, which I'm pretty happy about, and I got the legs done, which I'm pretty happy about. Yeah, so I had originally used the jointer and planer on a bunch of these boards, and after a few passes, I was wondering, why does this board look so much worse than it did right off the shelf? And I realized it had to do with reading the grain. And that was after I sought some advice on how to get it done, because I looked at these boards and I was thinking, these all look reasonably flat. They're just not level with each other. I probably should see what I can do with these before I actually do glue them up. And I was told it had to do with the grain. And after fixing that up, these were much more even. And after using the jointer to try to edge joint, and also using the table saw just as an experiment to see which one worked out, I ended up liking both of them about as much. But I ended up going with the table saw just for practice. These fit much better. One of the things I did was I alternated the grain direction in terms of the end grain, so that way they would make like the squiggly shape to help reduce cupping. It ended up still cupping at the end, but not as much as I'd expected. And I realized it might have had to do with that I forgot to alternate the direction for one of the boards. So there was one section where there were these two upside down U shapes right next to each other that I forgot about. But it otherwise turned out pretty well. This is what it looked like before gluing it up and clamping it. After clamping and everything, it looked better than this, I think. But I didn't end up getting a picture. Unfortunately, I put it through the belt sander and it left a burn mark on one board, but I'm still pretty happy with that. I ended up using the 3D printer so I could make a router template that would make the mortises, the holes that all the tenons would fit into. I ended up using that to test out different sizes of mortises on a practice piece. After choosing the depth that I wanted and choosing the width that I wanted, this is one of the design changes that I made. I ended up not having the mortise right down the middle and not like a certain spacing from the top of the board to the pretty much from the top of the board, which threw off how I was going to do the aprons. I still am pretty happy with how the mortises turned out, but because I stuck to the old design and the old cut list that I wrote, I accidentally ripped the aprons so narrow that they didn't line up with the mortises as well as expected. That either if I wanted them centered, there'd be a big gap here, or I could have them flush with the top of the legs, but then you'd see a small gap here. So I ended up not doing that. I decided I would work on the aprons later. But this was one of my practice pieces, which I'm pretty happy about. Paul recommended that I hand cut the tenons. And so I tried using the Japanese handsaw, and it looks pretty rough, but I'm pretty happy with how it turned out. Yeah, so I figured, oh, well, given the amount of work this took, do I want to go through with making 8 of these? And I thought, yeah, but assuming I didn't rip down the boards too narrow. So I'm gonna keep working on that.
That's really cool. I love that you 3D printed a jig for the router. That's like the lovely world of integration where really, I think that all of these skills get better the more of them that you have. So when you realize like, oh, I want to make this cut, but it would be really hard to do with what's available, you just 3D printed yourself a solution, right? And that's just kind of wild. So great job with that. I hope that you're having fun. If your board is my like first thought, and this is maybe not the solution you're going for, but if your apron stretchers are just a little bit too short, your legs are a little bit too tall, I think I would probably glue them up and then sand the end grain on the top of the leg just a little bit shorter so that it comes down to meet the stretcher. I mean, I don't know exactly the dimensions that you're talking about, but that would
Okay, yeah.
definitely be a cool a way to solve the problem.
I ended
That
up
could work.
ripping the board so narrow that the bottom of the board would be pretty much right where this mortise ends,
Oh, got it. Yeah.
which is doable. But I just figured that this is a project that I know I want to do, and I want to like try out getting
Yeah.
it looking really nice. So I figured instead of like rushing it through, I might as well take my time with this, especially since these tenons are so hard to make. It's going to take practice.
Yeah,
I
absolutely.
figure it's worth it.
Yep, totally. If you have a long-term plan, sometimes you know whether you want to have a project be a quick one or a good one. Those don't usually pair well together. So totally makes sense. Take your time, get something that's nice, especially if it's going to sit in your living room.
Yeah, he's definitely going to eat this. So having these little pegs that can just pull a piece off, make a new one, and pop a new one back on, really helpful.
Yeah, that's really great. Awesome work, Vincent. Very nice. And then let's see, we've also got, let's see, we'll make sure that we're headed on our way. And then we've also got Robin and Yushi. If either of you are around and able to share, we'd love to hear what you're up to this week.
Sure.
Sure.
So I have started a charcuterie board, but it's actually still in Make Haven. If you wanted to hold it up for them, do you?
Yeah, I can go grab it.
Thank you.
Right
Yay.
here.
Yep, that's it. So I just clamped the two boards together, and I just let the glue dry, and I'm actually gonna come in tomorrow and finish. So that's just how it looks for now.
Yeah. Well,
So
and
yep,
it's-
I'm
it's
making a
always-
charcuterie board as well. I forgot her name, but she also said she made a shorter one too. I was aiming to get a shorter one as well.
Yeah, I think that your charcuterie board and Alina's are very much like a match set of nice little display boards. Yeah, small, medium, and large all happening. Yep, that's lots of fun. Cool, very nice, thank you. And then Yushi, if you're around and could share. Oh, thank you.
Hi. Hey, sorry to came in late today. Had a Zoom
You're
meeting
all
that just
good.
didn't want to end.
Those
So
are rough.
I spent a little bit of time just exploring the woodwork whole area, and it just trying to get used to get familiar with all the tools and stuff. And I guess I fell in love with the little scroll saw. And this was the first thing I made. Yes. Here, so this is my name, the last word of my name, and then made two other little things. One is still in Make Haven. This was the other one I brought home. So yeah, these are just like little name stands. So you can stand on your table. Yeah, just little things like that. And even surprisingly, even with these little things, there are so many things that you need to consider. I was definitely learning, I mean, things that I wouldn't think would matter. Where to draw the where you drill the holes, and then what angles to go in, what angles to come out, and what are some ways that could make this like different ways to make it. Because for this one, for example, I was trying to make a 3D one, but like 3D as in like you have the characters here and then you have the characters here. But then this was my end result. I didn't make this one here, but it could be my next little project.
Yeah, the scroll saw is fascinating. And I feel like you really nailed it on hitting delicate shapes on the scroll saw, which is completely an art. And I'm excited to see that you're so into it, because you'll get better with practice. And then by the time we reach a couple weeks from now, if you're still playing around with the scroll saw, you can crank out some beautiful things. If you haven't met Darcy yet, you totally should. He makes signs for like shops and stores and all sorts of stuff. And he just started using the CNC, but he was using the bandsaw and the scroll saw to do lots of really like large scale, but nice letter work and signage. And like he made a giant shoe on one of them. What are other shoe and like car stuff. There's all sorts of fun things that people have made. And it's really, really an art on top of all the other things. So you did great. And your other one is I'll check on it and give you an update, but it's in the fume hood because you sprayed it with poly, right? Yep, cool.
Thank you.
Yeah, thanks for sharing. And brings us through all of our show and tell for everybody that's here. I want to say great job, everybody. There's all sorts of cool stuff that was made. I'm really excited to get a look at all the projects as they come along. And I hope that you are too. It's fun to share. We can take a better look at all the stuff that's in the room in a minute. But one of the things that's really cool to see, and the people who are online did a great job of showing us all, is the documentation piece. It's something that is tricky to remember to do all the time. Getting a picture as you're in the middle of it is a deliberate effort that has to happen. But it looked like several of you were on that way. And so I definitely want to give a reminder. My computer is a little sad, so it wasn't able to pull up websites of everybody's things at the same time. But I'll try and get that remedied for the next round so that you can show off all the cool things that you've been up to. The Metal Shop, I think, does a great job of having good opportunities for pictures because you've got all sorts of weird new tools to play around with and look at. And it's a good spot to set things up and really get some good photos, because it's a space where a little bit slower, more deliberate work often happens. So it's good for photos. And so with that, I think we had a really lovely show and tell. I'm very excited to get started in the Metal Shop. We have Coleman and Mara are both here. So we're going to like run them down and try and get there. There he is. That's Coleman, one of our Metal Shop facilitators. And so we're going to chase him down and try and ask a few questions before he unloads all of his wood from his car. And so that's our game plan. But other than that, the facilitators are in a bunch this week. I'm going to be in on tomorrow, Tuesday. I'll be in on Thursday and Sunday. But the facilitators are coming in mostly on weeknights. So if you can try and come in another weeknight this week, that's probably going to be the best bet to get a badge. And really, if you're looking for which ones to get badges on, I would definitely recommend those three: the MIG welding, the horizontal bandsaw, and an angle grinder or some other wild card badge would be a great place to get started. So that is that. And so for everybody who's remote, I think that we're all done. We're ready to go. And for people in the room, let's go wander into the Metal Shop and see what sorts of fun things there are. So see everybody. Have a good night.
See ya.
Bye.
See
Have
ya.
a good night, everyone.
Bye. Have a good night.
Let's wander, but let's not wander too close to the welding station.
Yeah, that's right. We got to stay out of we got to keep our eyes protected. See you, Vincent.
Good night.